CVCA's robot, Thanos 1403, is a versatile and robust machine. It is the Swiss Army knife of robots, able to complete any task given by the off-the-grid challenge. This is the main system of our program. In this, we switch between our drive mode and the 4 different tracks of autonomous mode to follow the 4 lines on the field. Each line has a corresponding button on the controller. The buttons trigger a mode switcher that places them into a chosen mode, and we have a track selector subsystem that receives the signal of the mode switcher. The 4 autonomous tracks and the driving system all send values using buses to the actuator subsystem. This is where the values are received and the actuators are told what to do. This is a general drivetrain for Thanos 1403. The left and right joysticks correlate to the left and right motors respectively. Holding down the 8 right button changes the robot into what we call slow mode. Along with this, we create a subsystem to help keep our drive system organized. There are 2 specific parts to the drive subsystem. The first part is the slow mode, and it reduces the move speed of the robot to 50%. The next part of the specific drive subsystem is the main drive, and it includes the motor controls for the wheels. We have subsystems that make the deadband related values easy to edit. Also in this section of the code is a slow turn subsystem. The shoulder and the elbow are both articulating and use simple full speed movement of the motors. A subsystem is used to allow the programmer to easily change the range of motion of the servos by adjusting the numbers in the constant block outside the subsystem. We use latch blocks to move between 2 values. The box grabber, upper claw, and lower claw use the 8 right, up, and down buttons respectively. This is the subsystem that the servos use to go between 2 values. You see this subsystem in the box grabber and raptor claw programs. Next are the 4 autonomous tracks. The image shown is one of the tracks with 2 turns, but the 3 other tracks are still similar. We make the robot move in the path of the autonomous tracks. The tables show the path of the wheels. High parts of each graph make the corresponding wheels go fast, and the low parts make them go slow. Here is the actuator subsystem. This is where all the values from the bus blocks are received. We included this because we had to give actuator inputs from 5 different modes. Using buses allowed us to do that without the values clashing with each other. The CVCA Royal Technic Robotics team thanks MATLAB and Simulink for giving us the opportunity to use Simulink to program our robot.